So the second one should be quite straightforward. Hence, find the vector equation of line PQ. PQ, we need PQ. So now we have P and Q. I've already got P and Q, so I'm going to find this line here. So it's P to Q here. Okay, so I hope you can just visualize this line here, P to Q. Now P to Q, you need two position, as in two points to form a line equation. That is what we know. It's very quickly we can just write down the line PQ is actually just R. Then you can just use either OP or OQ, it doesn't matter. So you can, I'm just going to use OQ maybe. So O00. And then this is 1/3 A. 1/3 A. Okay, plus lambda P to Q. Okay, P to Q. I'm going to just find P to Q. This is a direction vector. So a direction P to Q is just Q minus P. So this is 0, 0, 1/3 A minus of A to AA, which is actually just negative A, negative 2A, and negative 2/3 A. We can just multiply with negative 3. That will be 3A, 6A, and 2A. Okay, so it's 362A. But A is a constant, so or we could just multiply with 3 over A, because the A is just redundant. So the direction will just be 362. Okay, so this case here will be 362, where lambda is real value. So you can just use this as your, sorry, this A is, I'm very used to, it's a constant, so it's A over 3. Okay, yeah, it's not a vector here. You can leave it like that. You could also write in this, you could just use OP as well. Now, you can't simplify A here, okay? You can only simplify A here because this A absorbed in this lambda will be another lambda, which is actually a real value as well. Okay, so let's look at part 3.